You know, in the world of AI, the whole point is to make models smarter, right? But what if one of the most popular ways to train them was actually doing the exact opposite? Today, we're diving into a real head-scratcher, an AI training paradox, where the very quest to make an AI smarter was, believe it or not, shrinking its mind.
So get this, researchers stumbled upon this super weird paradox. A popular technique, one that was supposed to make an AI a better reasoner, was actually shrinking the total number of problems it could solve. It's kind of like winning the battle, but completely losing the war.
Now, at the heart of this whole mystery is a technique called RLVR. It's a really common way to sharpen up an AI's reasoning skills. And the idea is pretty simple. The AI tries a problem, and a verifier just gives it a thumbs up or a thumbs down, correct or incorrect, like getting a grade on a math test. You'd think that after enough practice, the AI would get better, right? Well, not exactly.
And here is the core contradiction, the crazy part. The whole goal of RLVR was to push the AI's reasoning boundary, to make it able to solve a wider range of complex problems. But what researchers found was that it was creating this kind of intellectual tunnel vision, making the model better at a few things, sure, but at the cost of its overall problem-solving ability. So obviously, this discovery set off some major alarm bells. Why was this training method, which seemed so logical, not working the way everyone thought it would? Researchers had to dig in and figure it out, and they eventually unmasked two key culprits responsible for this whole mess. All right, culprit number one is a phenomenon called negative interference. And really, it's exactly what it sounds like. It's when the process of learning one thing actually gets in the way of knowing something else. Here's a way to picture it. Imagine the AI's knowledge is the super intricate web of connections. Well, when RLVR comes in and strengthens one part of that web to solve, say, problem A, it can accidentally snap the delicate connections needed for problem B. So the model learns a shiny new trick, but in the process, it completely forgets an old one.
This quote from the research paper just nails it. This isn't some minor little side effect we're talking about. It is a fundamental dynamic of how this training works. The model is basically being forced into a trade-off. The more it zeroes in on one type of problem, the more it actively unlearns how to solve others.
And here's the paradox in action. If you only look at the model's first attempt at an answer, what the researchers call pass it one, everything looks fantastic. Accuracy is going up, the model looks smarter. But the hidden problem, the scary part, is revealed when you give it more tries, or pass it K. Its ability to find any correct answer, even if it takes a bunch of attempts, actually gets worse. It's like it's mastering its favorite answer, but losing the ability to even think of other options. Okay, so if negative interference is what's happening, our second culprit explains why it's happening so badly. It's something called the winner-take-all effect, and it's a direct result of how the AI is forced to practice.
Now, this is the critical detail, the piece of the puzzle that changes everything. The system is on policy. And what that means is the model only gets feedback on the answers it comes up with on its own. It's not being fed a wide variety of possibilities. It's basically living in an echo chamber, only ever practicing what it already thinks.
And you can probably guess the consequence of that. Since the AI only learns from its own answers, it naturally just spends more and more time on the problems it's already confident about. And the stuff it's kind of iffy on, well, it almost never tries those, so it gets zero feedback, zero practice, and they just fade away. The AI basically becomes this very diligent but totally misguided student. It keeps drilling the flashcards it already has memorized because, hey, it's a guaranteed win, a guaranteed reward, and meanwhile, all the tricky flashcards it actually needs to learn just gather dust at the bottom of the pile. It's over-practicing its strengths and completely ignoring its weaknesses.
And yep, the hard data confirms all of this. Researchers sorted problems into two camps: winners, the ones the model was already pretty good at, and losers, the ones it was less sure about. And after RLVR training, the winners got even better, but performance on the loser problems, it actually got worse. It's like they were just pushed aside and forgotten.
So we've got our culprits, negative interference, which is supercharged by this winner-take-all dynamic. And yeah, it might sound pretty bad. But after pinpointing the problem so clearly, the researchers came up with a solution that is just so simple and honestly brilliant.
They called their new algorithm SELF, and its core idea is to completely flip the script on how the training works. Instead of letting the AI get rewarded for practicing what it's already a champ at, SELF forces the model to confront its mistakes. It's basically a training program built on humility. So just to recap, the old way, a method called GRPO, it rewarded the model for getting any answer right.
And that's what created that winner-take-all echo chamber, where the easy problems hogged all the attention and practice time.
But self? It introduces a totally game-changing new rule. It pretty much says to the model, hey, if you got this right on your first guess, we're done here. We don't need to practice this anymore. Let's go work on the stuff you're actually struggling with.
And the results are, well, they're just dramatic. Take a look at this chart. It shows the overall problem-solving range. The base model before this training started out pretty strong. The old GRPO method, it actually made it way worse, just like the theory predicted. But the new self method, whoa. It didn't just fix the damage, it blew right past the original model's performance, unlocking a ton of hidden potential.
Okay, so what's the big takeaway from all of this? Why does fixing this one kind of niche training method matter so much for the future of AI?
So let's bring it all home. We saw how a seemingly good training process was actually backfiring, causing this intellectual shrinkage. We identified the two culprits behind it, and then we saw how a really simple solution, just forcing the AI to learn from its mistakes, not only fixed the problem, but unlocked its true potential.
And this is about so much more than just getting better scores on a test. This is a huge step toward building AI that can reason flexibly, that can be creative. It's about moving away from models that just get better and better at a narrow set of skills they already have, and toward models that can truly explore, adapt, and find totally new ways to solve problems.
And that's what is so exciting about this whole thing. It really leaves you wondering if a simple shift in perspective from rewarding success to studying failure can unlock this much hidden talent. What other basic assumptions that we have are holding AI back right now? What else is out there waiting to be unlocked, not by building bigger and bigger models, but just by training them a little bit more wisely?